Welcome to Cisco HyperFlex video series. This is Introduction to Hyperconvergence. Hyperconverged is a quickly growing trend in the data center. This is often being mentioned in conjunction with cloud infrastructure, and today's data center is increasingly moving towards private or public cloud. But what does hyperconverged really mean, and why is it so good as a cloud platform? First, we need to understand how the data center evolved, and what were some of the challenges that it had to overcome. Early data centers had individual servers. These bare metal servers were self-sufficient, standalone, and their systems worked like your home computer. Your computer has a processor, memory, and storage disks. This design works well at home, but in the data center it has limitations. For example, every server only has so many disk slots available. When you can no longer add a disk to a server, you have to replace the entire system. This was expensive and caused interruptions. You had to take the server offline to upgrade it, and even when you replaced the server, you had to copy the whole storage to the new machine. This is why centralized storage was introduced to the data center, storing all the information in one place. Now, since the storage was no longer in each individual server, servers received the information from the central storage array. To allow the data center with a central storage to scale, a storage area network, or SAN, was added to the data center. SAN connects the central storage to the server. This introduced some additional administration overhead, and it did not solve the problem when servers failed. Whenever servers failed, the application running on the server became unavailable as well. Clusters were introduced. These groups of servers provide a fail-safe when a server fails. There are other servers which can instantly take over. Now you could easily replace parts since you do not have any downtime. Now access to storage and high availability were solved, but everything was done by the operating system. If you wanted to move the system to another server or add a server, you had to go through all the installation steps each and every time. The workload distribution between the servers was not perfect as well, since you could still have servers which were barely used and no way to easily redistribute the load. Virtualization solved that. A virtualized server has a hypervisor, which is the actual operating system on the computer. Then you create files on the hypervisor and install an operating system in such a file. The hypervisor gives you tools to see the screen of a virtual machine even without a monitor attached, and ways to manage the installed operating systems. Now, with the help of a hypervisor, many operating systems can run on a single server. Each individual operating system is a virtual machine, or a VM for short. A great thing about the hypervisors is that it does not matter on which server the VM was originally installed. You can move VMs between hypervisors on different servers, if you want, and the VM will still work. With modern hypervisors, like VMware ESXi, you can move virtual machines between servers in a powered-on state. Now, you can rearrange the virtual machine so that the workload distributes itself to all the servers in a cluster, bringing utilization up and costs down. This three-part configuration of central storage, SAN, and servers is something that you would very typically find in today's data center. But since each individual part can be a completely separate system, often from different vendors, this means that a lot of configuration and knowledge is required to deploy such a solution, and a lot of resources have to be invested. Cisco eased that by providing validated solutions with tested configurations. These are the so-called converged systems. FlashStack, vBlock, VersaStack, and FlexPod all use storage from different vendors combined with Cisco servers and switches. The systems are much more straightforward to deploy, since Cisco provides validated designs which were tested and well documented for a given use case. But converged has limited scaling. Once the capacity of the solution is reached, another converged infrastructure has to be added. This is not ideal for modern business, which demands experience we are used to in public clouds. Start today small and expand only when you need to, without scaling limitations. This is where hyperconverged comes in. It moves storage back into the server, just like when servers first appeared. Hyperconverged adds an additional software component to each server, which merges the storage of all the servers into one large unit, which all servers can use. All the functionalities of the centralized storage remain, but are now done distributed across all the servers in a cluster. Each individual server is a hyperconverged node in a cluster, and the information is stored on servers in such a way that if any one server fails, the rest can still operate normally. The hypervisor, which is a part of the hyperconverged solution, takes care of the high availability and low distribution of individual virtual machines, and each additional node just adds more to the common pool of resources. With hyperconvergence, there is no more SAN, or centralized storage. No more silos, just a bunch of servers talking to each other and presenting themselves as a unified pool of resources to the virtual machine administrator. This makes adding more hardware a breeze, and you can only add as much as you currently need, since all you have to do is buy another server and you will have more resources. This single flexible system that you can easily expand is exactly the idea of a cloud platform. This was Introduction to Hyperconvergence. Thank you for watching.